So given this distribution, we may also be interested to find the median. I don't know whether we did the median last time, but the median is easy to prove that 1 is the median, because if you have probability of x is equal to 1 over 6, 5 over 6, x minus 1, then for every x, this value is less than or equal to 1 over 6. But this is for the mode. Yeah, we give the mode, which is this, which is P of 1. So this shows that P of 1 has the highest probability. In some instances, when you will be asked to find the mode, you will have to, when we get to continuous distribution, we will have to use calculus, for example. In continuous distribution, we are going to have a continuous function, which we will find the derivative and then take the point where the derivative attains its extrema, the minimum, the maximum, and then use that to determine which point is at the mode. So we also try to solve the equation that will give us the median. It was an equation, I left it there and I asked you to solve it. So now, if we have a random variable x, we can do what we know in mathematics as composition of functions. We can apply another function g on x if it's a numerical value function, and then define another random variable y. So that is what we have here. If g of x is a numerical value function, that is, the values are numbers, and the domain is the subset of real numbers, then y equals to g of x is another random variable. We have been using that. As I did this transformation, we can change x to y equals to x minus 1. That's the transformation. That is what we are generalizing by this. So when you do that, what happened to the new random variable? So we are saying here that if x is a random variable, and g is a function from R to R, that's what we call a numerical value function. It's function from R to R, and y equals to g of x is also a random variable. Is a random variable. Remember that a random variable is just a transformation from the set of outcome S to the set of real number. So we will say that X is from S to R, and G is from R to R. So you see what G does. G can be defined as from S to R. That is, it takes X, which is a subset of R, to R. So it's like a composition of function. X is here, and G is here. So G of X is here. G of X, you think about X as a function, though we like to look at it as a set by considering the range of it, the values that it takes. That is what actually makes X as a random variable. So now, and the mean of G of X, the mean of G of X is sum of G of X Example, if G is a linear function, then we will have that E of G of X is equal to sum of AX plus B times P of X. Which is equal to sum of AX times P of X plus sum of B times P of X, which is equal to A sum of X times P of X plus B sum of P of X. So sum of X times P of X is the mean of X. This guy here, sum of X times P of X, is the mean of X. So this is A times E of X plus B. Remember, what did we say was the sum of all the value, sum of P of X? The sum of P of X here, anybody remember what it should be? Yes, it should be 1. So that is why we get this, which is the linear transformation of a random variable. So we have actually established the fact that E of AX plus B is equal to A of X plus B. Let's do some kind of application here. Remark. If X is a random variable, then E of X, the mean, is also called the first moment of X. The first moment of X. And E of X squared equals to sum of X squared times P of X, from what we have just said, is called the second moment. It's called the second moment of X. In general, E of Xk is called the kth moment. We are going to come back to moments. Moments are very useful in probability, and then we will soon need the second moment. So let's look at variance and standard deviation. Let X be a random variable. With probability distribution P of X. We are assuming that all our random variables are discrete because we have not yet learned about continuous random variable. X is a random variable with probability distribution. P of X. Then the variance of X is denoted by sigma square X, or variance of X, and defined as variance of X is equals to the expectation of X minus mu square, where mu is the mean of X. And the standard deviation is the square root of the variance. The standard deviation is the square root of the variance. Now we want to observe that we had a mean mu, and we define a new function g of x equals to x minus mu square. So if we can define the mean of g of x as the variance of x. So it's actually the expectation of x minus mu square. You could also think about this as x minus mu is the deviation from the mean for each value. X minus mu tell you how mu deviates from, x deviates from mu. When it is negative, it means it's below. If it is positive, it's above. So the variance is the expectation of the square of the deviations. And the standard deviation is the square root of the variance. This is to explain the reason why we have the word standard deviation for variance. Variance is the expected square of the deviations. And the standard deviation is the square root of the variance. Example. Find the mean, variance, and standard deviation of x defined by this. Negative 1, 0, 1, 2 of x negative 1, 0. I will put here 1 over 5, here 2 over 5, here 1 over 5, and here 1 over 5. This is a simple finite distribution. So then the mean of x will be E of x equals to minus 1 times 1 over 5 plus 0 times 1 over 5 plus 1 1 over 5 plus 2 1. So this is 1 over minus 1 over 5 plus 0 plus 1 over 5 plus 2. Which is equals to 2 over 5 is 0.4. Just rewrite it like this. This is x. This is P of x. This is x minus mu. X minus mu square. Negative 1, 0, 1, 1 over 5. Here is 2 over 5. Here is minus 1 over 5. And here is 1 over 5. We do x minus mu. That is minus 1 minus 0.4 minus 1.4. 0 minus 0.4 minus 0.4. 1 minus 0.4. 2 minus 0.4. 1.6. Now we do 1.4 square. Can you use your calculator to find 1.4 square? Might be 1.96. Anybody has a calculator? 1.4 square. Remember that negative 1.4 is negative 1 minus 0.4. That is x minus mean. What is 1.4 square? One point 1.4 square, 1.6. Then we have 0.4 square, and 0.6 square, and 1.6 square, 1.6 square, 2.56. Now we can add these numbers. Okay. Now, 1.96 plus 0.16 plus 0.36 plus 2.56. So this gives us 5.04. So we can say that, I'm sorry, this does not make any sense. What I just did does not make sense. I was doing it as in statistics. So the next thing we will do is x minus mu square times p of x. X minus mu square times p of x. That will mean that we will multiply 1.96 times 1 over 5. (0.392). Then 0.16 times 2, that is 3.2 divided by 5. That's 0.64, I think. We have 0.16 times 2 divided by 5, 0.064. There is something here like a minus. This is 1 over 5. It's a probability. Now 0.35 divided by 5. 0.36 divided by 5. 0.092. 0.072. And then 2.56 divided by 5. 0.512. 0.512. Now, to check our answers, we can say this plus 0.072 plus 0.064 plus 0.39. Something is wrong here. Let me check it again. That means something is not correct here. 1.4 square 0.392. Yeah. Oh yeah, this is where the problem is. 0.4 square. Square 0.16. 2.32 divided by 5.064. Okay, now 0.6 square divided by 5.072. Okay, so this is what I was doing did not make sense. I was doing something else. So sorry for that. So to get the variance, we add these numbers. It's 1.04. So the variance of x is equal to 1.04. After all of this, do you understand how the procedure? It's a very simple thing to do. Though I'm going to show you an easy way to do it, I want us to see how this is complicated, and there is another formula that is better than this. So the reason why I did this is for you to appreciate why we need the formula I am going to give you now. Okay, remark. Let x be a random variable with mean mu and with mean mu. Let's just keep it this way. The variance of x is variance of x is equal to e of x times e of x, which is e of x squared minus mu squared. E of x squared minus mu squared. Let's prove this. It's a remark, but I would write proof. I could just say for, because by definition, the variance of x is the sum of x minus mu squared times p of x. As our definition of the variance is e of x minus mu squared. So we can say this is equal to sum of x squared minus 2x mu plus mu squared times p of x. I just expanded x minus mu square. So which is equal to sum of x squared times p of x minus 2x mu times p of x plus mu square times p of x. So we will distribute the sum, which is sum of x squared times p of x minus, we can take these 2 and mu out, sum of x times p of x. Because in a sum, constant can be moved out of the sum as a factor. That is why I move this 2 mu, 2 times mu, because mu is a constant. 2 is a constant, I can take it out of the sum. Then plus mu square times sum of p of x. So this guy is what? E of x squared minus 2 mu times E of x. This is E of x. And then plus mu square, because the sum of P of x equals to 1. So now remember that this E of x is the same as mu. So this will become E of x squared minus 2 mu squared plus mu squared, which is equals to E of x squared minus mu squared. So let's do the same example first. The example we just did. If we take that example, x, P of x, negative 1, 0, 1, 2, 6, 1 over 5, 4 over 5, 1 over 5, 1 over 5. So what we want here is the mean. We know the mean, 0.4. The mean is 0.4. So I will find the square of x. This is 1, 0, 1, 2. I'm sorry. The square of x is 1, 0, 1, 4. So e of x squared will be 1 times 1 over 5 plus 0 times 1 over 5 plus 1 times 1 over 5 plus 4 times 1 over 5. This gives us 2, 6 over 5. What is 6 over 5? 1.2. So the variance of x is e of x squared minus mu squared, which is 1.2 minus 12.16, and which is 1.0. So we can see, even though I'm using easy numbers, that the second formula is better than the first one. And the standard deviation of x is square root of 1.0. Which is let's just say 1.02. Let's do one more example. You pay $2 to play a game. Consisting of rolling a die and win the odd number you play. And nothing if the number is even. So you pay $2 and roll a die. If the number is even, you lose. If it is odd, you win the number you play. What is your expected profit? Find the variance and standard deviation. So to do that, we will make a distribution for the revenue. The revenue is what you get. if you play an even number, let's say 2, 4, or 6, you lose your $2. So let's put it this way: 1, 2, 3, 4, 5, 6. If you play 1, you lose $1. If you play 2, you get nothing. Let me not go this way. Sorry for that. I wanted to do it this different way. So if you play 2, 4, or 6, you get nothing. That is, your revenue is 0. If you play 1, 3, or 5, you win the number. For 1, you win 1. For 3, 3. And for 5, 5. So you get 0 with probability half. So we can say that your expected revenue is 1 plus 3 plus 5 over 6, which is 9 over 6, equals to 3 of 2. That's your expected revenue. And your profits is revenue minus cost, which is 3 over 2 minus 2 equals to minus 1 over 2. So your expected profits is minus 1 over 2. We could also do directly, let's call it gain, the distribution of gain. The distribution of gain is when you get a revenue of 0, you lose $2. When you get a revenue of 1, you lose $1. When you get a revenue of 3, you win $1. When you get a revenue of 5, you get $2 profit. So 1 over 2, 1 over 6, over 6, 1 over 6. And we will have expected profit. We'll call it gain here. This is like 3 over 6. 1 over 2 is like 3 over 6, so that I do the same thing. 3 times 2 minus 6 minus 1 plus 1 plus 2 divided by 6. This is how we are getting to time. You can complete this one.